There is a question about polynomials. So, directly in your mind should be remainder theorem, factor theorem, something like that. And then they tell you that Px is a cubic polynomials. This is a very good demonstration that you must read the question very carefully, and you have to think about the implication of cubic polynomials. So, cubic polynomials, that means it is Px should equal to something x power 3 plus something x power 2 plus something x plus something. It should be this format. And then they tell you that px divided by x minus 1, then the remainder is 50. When px divided by x minus 1, then by remainder theorem, you should know that the remainder is equal to p, and then put a suitable x inside to make the divisor become 0. What minus 1 give you 0? Of course, it's talking about 1. So what they tell you, and then they tell you the outcome is 50. So they just simply tell you p1 equal to 50. In your exam, you don't need to write this stuff. You just simply write that, oh, p1 is equal to 50. And also, they give you something like that. When px is divided by another thing, so p put a suitable value to make divisor become 0 will be negative 2. P negative 2 is equal to negative 52. But we don't know how to proceed to make good use of this information here is because they didn't give us px. They just simply say that it is a cubic polynomials. And another part, they tell you that px is divisible by 2x squared plus 9x plus 14. Just like what we mentioned, the major difficulties is we don't know anything about the original polynomial. That's why we try to use this information to build up px. Since px divisible by 2x squared plus 9x plus 14, so we know that px should be something times 2x squared plus 9x plus 14. Now come to the key point is you have to guess the format of this something so that you can make good use of these two equations. What time this item will give you cubic? Can it be x squared? If it is x squared times 2x squared, it will give you x power of 4. So this is not possible. In reverse, can it be just like 5? Let's say 5 times 2x squared will give you 2x power of 2. So it's contradict to the cubic root here. So the only possibility is another factor. It should be something x plus something. But of course, you won't use question mark like this. So for more systematic way, we let this one be ax plus b. And then our mission is to use these two equations to solve what is a, what is b here. So go back to p1 equal to 50. 50 is equal to, replace every x by 1, 8, 2 plus 9, and then plus 14. This will give you 25. Both sides divided by 25, a plus b itself is equal to 2. And also, p negative 2 is equal to negative 52. So again, replace by using the original function, replace every x by negative 2. Negative 2a plus b, and then handle this bracket carefully. Negative 2a plus b itself is equal to negative 52 divided by 4. That means negative 13. We get two equations. So a plus b is equal to 2, and then negative 2a plus b is equal to negative 13. A minus negative 2a is equal to minus negative 13. A equal to 5. Since a plus b is equal to 2, so a 5 plus b is equal to 2. B is equal to negative 3. After this calculation, we know that px is no longer ax plus b, but we already know it's 5x and then minus 3. When px is divided by the factor 2x squared plus 9x plus 14, so and then the quotient is talking about this one. So the quotient is 5x minus 3. The major difficulties here, once again, is many students do not know what is the meaning of QP polynomial. That's why they can't let reasonable format of px, and then they can't use the given information here. After that, how many rational roots does the equation px equals 0? So we should write down to solve px equal to 0. Of course, we will prefer the factor format is ready to use. So 5x minus 3 is equal to 0. Or another case, 2x squared plus 9x plus 14 equal to 0. For the quadratic equation here, because we need to check is that rational or not. So just use delta may not able to answer the question. A more general method is to use the formula of quadratic equations. So the quadratic formula is x is equal to negative 9. Is because of the negative 31 here inside the square root is more than 0. That's why this is unreal root. Not real root, of course, that means it is not rational also. So in this question, we have one rational root here, and then we have no rational roots in this part. Our final conclusion is only one rational root. Of course, some of the students, if you choose to use delta to prove that no rational roots here, is still fine because we have no real roots here. But however, if you get a positive value of determinant of the delta, then you do not have strong enough evidence to identify whether it is rational or not. So using the quadratic formula here is more general method that 100% sure you can answer the question no matter which case it is.